Welcome back to Management 670 Business Analytics. I want to spend a few minutes going over a normal example or a problem that uses a normal random variable, that is a continuous function, to solve a business problem. So let's get started. Let's apply what we've learned in the continuous random variable section and take a look at a normal distribution example. Let's say we're a company called Pepzone. We sell auto parts and supplies. Since we've been in business for a while, we have some data that shows that we think that the daily demand is best described by a normal distribution with a mean of 10 gallons and a standard deviation of 3 gallons. So yes, the number of people that show up to a given retail location can be thought of as a discrete, but we did talk about how we can save some time and not lose very much precision by approximating this distribution as a normal. So we think we have a mean of 10 and a standard deviation of 3 gallons. Every day, we assume, is different and therefore independent from one another. So I have listed right there that the daily demand is distributed, that's what the tilde sign means right there, as a normal distribution with a mean of 10, standard deviation of 3, and therefore a variance of 9. Currently, our policy to replenish our supplies is to wait until we have 45 gallons left in inventory and then send off that request. And historically, it takes a lead time of about 4 days for that shipment to show up. Doesn't matter how much we're ordering, just that at 45 gallons, when we have that in stock, we realize, okay, place the order, and it takes 4 days by our estimates to get that. Store manager is concerned that we are losing some sales by stocking out in the meantime. What's the probability, the manager wonders, of a stock out given this current policy of 45 gallons? After that, what is the reorder point where we can change it to not have a probability of stocking out of more than 5%? And finally, what if we got a lot better at shipping the product and that lead time goes from 4 down to 1? Let's do the first question first and talk about X. And X is the demand given the lead time of 4 days. So we had the daily demand that was normal. Now we have to make a new random variable that takes into account what the demand will be over the entire 4 days. So what does it follow? Well, X is actually the sum of the 4 daily demands. We have the lead time of 4, and therefore the expectation of X building off of these properties from when we talked about distributions and random variables would be 4 times the daily demand. So 4 of 10 gets me to 40. That's going to be my mean or mu for X. The variance of X is also the sum of the 4 variances because the daily demands are independent from one another. There's no correlation at all. So it's the variance 4 times gets us to 36. So therefore, X is a normal distribution that has a mean of 40 and a variance of 36 or standard deviation of 6. So the probability of a stock out is when we have a number, X, large X, that is greater than 45 or more, since this is a continuous function. That can be rewritten as 1 minus the probability of being less than 45. And now I can standardize it. A couple ways we can do this, but I want to show that 1 minus the probability of z-score is just that 45 value minus the mean divided by the standard deviation. That gets us a z-score of 0.83, so we can look that up in the table, or in the lower right in Excel, we can put that into a cell and get that difference. That z-score value, or the .dist value, that 0.7977, would be finding the probability that the demand over 4 days was less than 45 gallons. So therefore, 1 minus that tells me the probability that will be more than 45 gallons, which is just over 20%, 20.23. And if you use the table, you can be off just slightly for that, maybe like 0.1%. Sure enough, here's the table, 0.83. So I find the row and the column right at 0.83. It's 0.7967. slightly different when we take the complement of that, and we end up with just about 20%, like I said. The second question was, what if the manager wants to change the stock out order to have just a 5% chance of running out during that lead time? So the lead time is still 4 days, but we get to choose when we make the order. So what number should we pick to get that probability of a stock out to 5% or below? This is kind of the reverse. So we'll use the inverse function. We can write this as which z-score has a 0.05. Since we're just interested in one direction greater than z, we call this a one-tailed test. So again, that probability is 1 minus p. So I get 1 minus 0.05 since we start with the probability, and then end up with 0.95. So from the table, I look and I want to find 0.95, and that's right in between 1.64 and 1.65. And in fact, if we are more precise and put that into Excel, we get 1.65 generally. So 1.655 is usually a nice approximation for that. So the corresponding value of x will be the mean mu plus this z-score that will give us 5% or z, and then right below that 0.05 times that standard deviation. We found out that what that z-score is. It's 1.645. So we then put in the mu and the standard deviation. Simplifies down to 49.87. That's the correct answer, but kind of hard to have 49.87 gallons precisely in inventory. So the realistic order would be to bump that up a little bit to 50. Since we're increasing that, going away from the mean, we actually will drop below 5% chance of a stock out, which is nice. So then we have an actual level like 50 gallons and pick up a small bit of probability. So it'll be under 5% for that. What if we get down to just a lead time of 1 day? What's that stock out probability? And then we want to keep that at 5%. Well, the 1 day demand is just what we started with, that daily demand. We know that was normal with a mean of 10 and a variance of 9, so standard deviation of 3. So the reorder point then is start with this mean, have the same z value that we got before, 1.645. Substitute in the standard deviation of 3. So again, we end up with a precise number of 14.935, but in reality, we should make that 15. Again, dropping that probability just under 0.05. That's a big difference. That lead time goes from 4 down to 1. We can wait much longer, from 50 gallons all the way down to 15, if that's the case. That lead time shrinks. So that is an example of various ways we can use the standard normal and some Excel functions to calculate some real life business problems.